Now, dear students, in this video we will learn another type of loop statement that is called the do while loop. The syntax for that do while loop is like, first you have to write the do, then you have to write the body of the do in these curly braces, and then after that you have to write while, and with a round bracket where you have to specify the condition against which this do while loop should execute. Then you have to write the semicolon. So what actually this will do, that the microcontroller when reaches over here, the microcontroller will sense that it's a do, then the microcontroller will execute all these statements over here. Like we have statement like the code statement of code 1, then we have, let me copy this, and then we have statement 2, then we have statement 3, let's write over here 2 3, and any number of statements you can write in this do statement. The controller will do first, what will the controller do, that the controller will execute the statement 1, statement 2, statement 3. After executing these statements, then the microcontroller will check condition. If this condition is true, then the microcontroller will again execute these statements. But if the condition is false, the microcontroller will not execute these statements. But what is the difference between this do while and the while we have studied in the previous video? The difference is that in do while, the microcontroller will execute these statements at least once before checking this condition. But in while, the microcontroller will first check the condition, and if this condition is true, then it will execute the statement. And but in do while, all the statements written in the do will be executed before the microcontroller checks the condition. But in while, the microcontroller checks the condition and then executes the statements written in these braces, curly braces. So let's check, let's comment this, so that these are just for understanding, they don't play any part in the code. So let's actually write the code. Let's say I am going to write this in void setup. Let's say we have do statement, then in the curly braces I am going to actually blink all these LEDs. So for that I am going to write digital write pin number 13 high. Let's copy this code, and pin number 13, then we have to have an LED at pin number 12, then we have an LED at pin number 7, and after that let's add a delay so that we can check the actually turning on and off the LED. For that, this delay function gives delay in milliseconds, so I am going to write 1000 for 1 second. So let's copy this code and let's add over here, and let's turn these LEDs off, right low. These are the functions that Arduino have provided, like which we are now using. In the do statement, what we have done, that we have turned on the LEDs. After a delay, we have turned off all the LEDs and then added a delay. And let's now add the condition, because we have written the do, then we have to write the while with the do. And in the condition, let's say we can write, let's say I declare over here a variable, let's say int, and let's say y is equal to 10. I have declared and initialized the variable y with the data type int, and I want to check if y is equal to 10. We have studied in these operators conditional operator videos, where we have checked that this what does double equal to do. If y has the value of 10, then this condition will be true. So now what will happen, let's just save this. What will happen that the microcontroller will first execute all the statements written in the do. After executing all these statements, then it will check if y is equal to 10, y has a value of 10, then it will again check these statements, and y do while will be executing until the y has a value of 10. As we have given the value y 10, so this loop will be executed. So first of all, we can also add another line to print something, serial dot print line, and let's write over here do while executing. We can get a message at the print serial monitor. So let's save this, let's run the simulation, and let's see what happens. Oh, there is some error. Sketch dot before token, let's see what we have. An error over here, while is equal to 1, void setup, serial dot begin, do serial dot print line. Let's run. We can see what we are digital. I think we have something missing. Yes, we have this over here, round bracket missing. So let's save this and let's run the simulation. Hopefully it will work fine. Now you can see that our LEDs are turning and we have received a message do while executing, do while executing. So this is because this condition is true, but at least they are executed once. Now to verify that if it's executed once, what I will do, I will intentionally want this condition to be false. So for that, let me save this, stop the simulation, and let's change the value of y to, let's say, 15. Let's save this. Now what will happen, that y has a value of 15 and this condition will not be true. So we have studied in the do while that the statements written in the do body will be executed at least once. So now you will see that when I will start the simulation, that these LEDs will blink at least once and you will receive this do while executing message at least once. So let's clear the serial monitor and let's run the simulation. Now you can see it's blink and then off. We have received one message and we have exited the loop because this condition was false. So we have hopefully we have built up an understanding that in do while loop the statements written the do is executed at least once. So let's try another thing. Let's say if I write all this statement from do while in my loop statement in the while loop function. This is actually a loop within a loop. So now what will happen, that when the microcontroller will reach over here at the while loop, let's remove this statement over here and let's save this. When the microcontroller will reach this while loop, and then we'll check do and it will execute all these statements. After that it will check this condition. As this condition is false in the current scenario when y is equal to 15, then this will exit to next over here, but this while loop will again come over here and again it will execute the do statements. So let's run the simulation. Let's see what happens. You can see it's on, again on. We have received a message. Now we are receiving again, but you can see the condition is false. This is because this loop is actually continuously running these do statements. So that is why if you write this type of loop in this loop statement, you have to make sure that such conditions should be countered in the programming so that you can execute your loop in a very well manner. So hopefully you have understood